before we perform this kind of integration, let me just tell you, if you're having exponent of x with respect to x, when you are integrating this, it means you are going to say this will be e is to x plus c, just like that, the same function plus c. But if you are having integral of a is to f of x with respect to x, it means that we are going to write the function, the weight is here, f of x there, but we shall say 1 over d of dx of f of x. So meaning, going to differentiate this function here, we divide by 1 and then we're going to say plus c. If you are given a function and you are integrating f of x with respect to x, you are going to differentiate the power, divide it, then write the function the way it is. So let me just show you what we're going to do here. If we are integrating this, we are going to differentiate the power. If you differentiate 3x with respect to x, we are going to get 3. So we are going to say 1 over 3, then we shall write the function the way it is, then we shall say plus c. This one, we are having 2 over 5. The power is 3x plus 4. So in order to integrate this, we are going to write the function the way it is. Of course, 2 over 5 was a constant. We can take it out and we remain with e 3x plus 4. And then we are integrating with respect to x. So if you are integrating this, remember 2 is just there, over 5 is just there. We are going to differentiate the power. If you differentiate this power, you are going to get 3x. We are having 3x plus 4. Differentiating this power, we are going to get 3. So we shall say 1 over 3 e is to 3x plus 4, then plus c. Because remember, anytime you are doing integration, you must add the c here. So the basic logic here is that whenever you are integrating exponential function, you must differentiate the power, divide it, and then write the function the way it is, then say plus c. E is to 2x squared plus 5x plus 4 with respect to d. Now, first we understand that we can be able to take this constant out, and we shall have free integral of e is to 2x squared plus 5x plus 4 with respect to d. So we have mentioned that whenever you are integrating an exponential function, first you need to differentiate this power. Differentiating the power, we are going to, of course, remember that we were having 1 over 3 times. When you are integrating this, you will differentiate the power and you shall say 1 over what you will get after differentiating the power. And then differentiating this power, we're going to get 4x, and the power is going to decrease by 1, so it will be 4x raised to power 1. Differentiating 5x, we're going to get plus 5. Then we shall write the function the way it was, 2x squared plus 5x, 5x, then plus 4. Then we shall say now plus c. Then now we can be able to simplify this further. It will be 1 over 3 into brackets. Of course, this can translate to 12x plus 15. E is to 2x squared plus 5x plus 4. Then we shall say plus c, which is our constant. Simplifying this, it will be 2 over 15. E is to 3x plus 4, then plus c. That's what it will simplify to, right? And this one, we're going to say we can take the constant out of the integral. We remain with e is to 4 minus 5x with respect to x. And then that means that integrating this, we are going to differentiate this first. And we shall say 4 times differentiating the power. We are going to get -5 here. And that will be -1/5, right? Then e is to 4 minus 5x, then plus c. And then we are done with that. Now, we have question number 5, and question 5, now we are having limits, and then we are supposed to evaluate this. How are we going to go about this one? We're going to say first, we are going to integrate this, but you see there is a power here. We cannot work it the way it is. First, let's say a is to 4x minus 5 squared. It will be a is to 4x minus 5. Now, if we open the bracket here, we are going to say this is going to be a is to 4x into a is to 4x minus 5, then minus 5 into a is to 4x minus 5. So opening this bracket, we are going to have this equivalent to a is to 8x. This time this will be minus 5 a is to 4x. This time this will be minus 5 a is to 4x. This time this will be positive 25. So which means working out this or putting the like terms together, we shall have a is to 8x minus 10 a is to 4x plus 25. Now this is what we are integrating from 0 all the way to 1, and we are doing that with respect to x. So first I had to expand this so that I reduce this to a value which I can be able to perform the integration. So let me just go ahead and now get some space here so that I can be able to substitute in whatever I have. First, I have to do the integration. Integrating this, we're going to differentiate the power and divide it. So it will be e is to 8x 1/8 minus, this one will be minus 10/4 e is to 4x. Integrating this, we're going to get plus 25x. So meaning we are going not to include, we are not going to include the constant because we have the limits. So we shall say this is 0 and this is going to be 1 there. So if we put 1 here, the first part of the equation will be into bracket 1/8 is to 8 because 8 times 1 minus 10/4 e is to 4 because 4 times 1, then plus 25 minus this is going to be 1/8. 1/8 is to 0 minus 10/4 is to 0 because 4 times 0 will give us 0, and then plus 0 because 25 times 0 will give us 0. Now this is going to be 1/8 is to 8 minus 10/4 is to 4 plus 25 minus 1 over n number is to 0 is 1, so 1/8 minus 10/4, and then we can be able to simplify that. Of course, this is going to finally become 1/8 is to 8 minus 10/4 is to 4. When we solve this one, simplifying that, what does it give us? Let's check what does it give us if we just work out this pattern on base 9/8.